In this video, we will practice modeling data in a given context using exponential functions. This is AP Pre-Calculus Topic 2.5. If you appreciate the content, please give it a like. Number 1. The number of worldwide deaths of children under 5 years old due to malaria has been decreasing in recent years. The table above gives the yearly number of deaths in thousands for children under 5 years old due to malaria for several years since 2006. Part A. Use the data in the table to create an exponential function model of the form y equals a times b to the x power, where y represents the number of deaths in thousands, x years since 2006. Turn on your graphing calculator and hit the Stat button. Hit Enter for edit. Enter the input values in L1 and the output values in L2. Now hit the Stat button, switch over to the Calculate menu, and scroll down to option 0. Or if you memorize that option 0 is the exponential regression model, you can just hit the number 0 instead. Before you calculate the exponential regression model, I recommend that you always go down to where it says Store Regression Equation and make it say y1. Hit vars, switch to yvars, hit Enter, and pick y1. That way the regression equation will be automatically stored as y1 in the y equals area. Hit Enter again. So your regression equation will be in this form, and here's your a and b. This equation will predict the number of deaths in thousands x years after 2006. Part B. Based on the exponential regression model found in Part A, approximately how many children under 5 years old are predicted to die from malaria in the year 2030? 2030 is 24 years after 2006, so the answer to this question will be D at 24. We had the calculator store the regression model as y1, so D at 24 will be y1 at 24. Here's how you type it in. Hit the vars button, go to yvars, hit Enter again, that's y1, and then use parentheses to evaluate y1 at 24. Kabam! Be careful, if you just put this number, your answer is wrong. The reason is that D of t is given in thousands. You can either say 120.303 thousand deaths, or you can say 120,303 deaths. Number 2. Before Facebook, we old people had MySpace, the first social networking site that reached a global audience. At its peak in 2008, MySpace was averaging over 1 million daily visitors. However, as Facebook rose in popularity, MySpace became less and less popular. The table shows the number of daily visitors to MySpace in millions, M months since January 2009. Part A. Use the data in the table to create an exponential regression model of the form y equals a times b to the x power, where y represents the number of daily visitors to MySpace in millions, x months since January 2009. I normally like to use v of m to match what we are given on the table, but they are specifically telling us to use y and x, so I'll do that. On your calculator, hit the Stat button and hit Enter for edit, and enter the input values as L1 and put the output values in L2. Next, hit the Stat button and switch over to the Calc menu. The exponential regression is option 0, just below the 9. So you can scroll down to it, or you can just type the number 0 like this. Before you calculate the regression model, I suggest you get in the habit of going down to where it says Store Regression Equation. And let's store it in y1. So hit the vars button, switch over to yvars, hit enter, and hit enter again. This will automatically store the regression equation as y1 in the y equals area. Hit enter and hit enter again. Kabam! This is the exponential regression model. Just substitute this value for A and this value for B. Part B. Based on the model found in Part A, how many daily visitors did MySpace have after 20 months? Include units. Part B is simply asking us to evaluate y at 20. However, be careful. Do not use the rounded numbers shown here in blue. Instead, I want you to use the regression model that was automatically stored as y1 in the calculator. That model has all of the decimals, so you won't get a rounding error. On your calculator, y at 20 will become y1 at 20. Just hit the vars button, switch over to yvars, hit enter, and enter again for y1. To evaluate y1 at 20, just put 20 in parentheses right next to it. Kabam! This is y1 at 20. Listen to me very carefully. You will not get full credit if you just write this answer. We need to be very careful about the units. This is supposed to represent the number of daily visitors. Does this mean we had about 7 visitors to MySpace? No. The data was in millions. So, you have two choices. You can write 7.1189 million visitors. This is a full credit answer. Or, you can write 7,118,900 visitors, which means the same thing. Part C. Let y equals a times b to the t power be an equivalent form of the model found in Part A, where t represents the number of years since January 2009. Find the values of a and b. Let's begin by copying down the model from Part A. Remember that in this model, x represented the number of months since January 2009. We need to rewrite this exponent using the variable t, which represents the number of years since January 2009. But whatever we put here, this expression still represents the number of months. What is the relationship between the number of months and the number of years? The number of months is 12 times the number of years. For example, if we are talking about 2 years, that's 24 months, 12 times 2. We are told that t represents the number of years. Therefore, the number of months can be expressed by 12t. Substituting 12t in for the number of months gives us this model. However, we need to simplify this in some way so that we just have y equals a times b to the t power, not b to the 12t power. In previous videos, we have learned that c to the a times b power can be rewritten as c to the a all raised to the b. That's what I'm going to do right now. Now we have this equivalent equation. We just need to find the value of b by raising 0.928 to the 12th power. But be careful, we don't actually want to use this rounded version. We need to use the version with all the decimals in the calculator. We need to raise this whole number to the 12th power. Kabam! So here is our new model, written in the form y equals a times b to the t, where a is 31.6016 and b is 0.4089. Number 3. After an alien spacecraft lands in the middle of Times Square in New York City, video of the event starts spreading rapidly across the news sites and social media sites. The number of people in the world that have seen the video of the alien landing can be modeled by the exponential function shown here, where m is the number of minutes since the videos were first posted online, between 0 minutes and 180 minutes. Part A. According to this model, how many people have seen the alien video after 2 hours? They are asking us to find y at 120 because m is in minutes and 2 hours is 120 minutes. Just enter this into your calculator. That's 4,670,683.641 people. Don't forget the units. Part B. Let y equals 1,391 times b to the s power be an equivalent form of the exponential model y equals 1,391 times 1.07 to the m power, where s represents the number of seconds since the videos were first posted online. Find the value of b. In the original model, the exponent represents the number of minutes. We need to rewrite this exponent in terms of seconds. However, whatever expression we put here still represents the number of minutes. The number of minutes is equal to the number of seconds divided by 60. For example, 120 seconds is 2 minutes because 120 divided by 60 is 2. S represents the number of seconds, so the number of minutes can be expressed as S over 60. Let's substitute this expression in right here. So here's an equivalent model involving S. You will agree that S over 60 is the same thing as 1 over 60 times S. We know that c to the a times b power is equivalent to c to the a all raised to the b. Let's apply this property to this expression right here. Now we can see that the value of b is everything inside the parentheses right here, 1.07 to the 1 over 60 power. Just put this in the calculator. Okay, I got a little bit carried away with the decimals, but b equals 1.00112828. Never ever just put the answer. Be sure to show your setup or you will not get full credit. Sometimes you won't get any credit. Part C. What is an appropriate domain for the model found in Part B? This was the domain in minutes. Since 0 minutes equals 0 seconds and 180 minutes equals 10,800 seconds, the domain for seconds would be S from 0 to 10,800. Number 4. The table above gives values for a function f at selected values of x. Part A. Find the equation of the exponential regression y equals a times b to the x power to model these data. Let's type the x values in L1 on the calculator and the f of x values in L2. Again, you hit Stat and then you hit Enter for edit and you type them in. To find the regression model, hit the Stat button, switch over to Calc, and for exponential regression it's option 0. You can scroll down or just type the number 0. Before you calculate the regression model, let's store the regression equation in y1. So hit vars, yvars, enter, enter. Now hit enter a couple more times, and kabam! There's the regression model. Part B. What is the value of f at 5 predicted by the exponential model you found in Part A? So they're asking us to find f at 5. We wisely let the calculator store the regression model with all of its decimals as y1 in the y equals area. Let's be sure to use that. If we use these blue numbers here, you will probably end up with a rounding error and lose points. In the calculator, f at 5 becomes y1 at 5. So let's do vars, yvars, enter, enter, and to evaluate y1 at 5, just put the 5 in parentheses. Kabam! That's it for Part B. Number 5. After Mr. Passwater finally relents and agrees to make a TikTok account where he only posts videos of him telling math jokes, as you can imagine, the number of people that follow his account grows rapidly. The number of followers for Mr. Passwater's TikTok account is modeled by the function f. The number of followers is expected to increase by 31.4% each week. At time t equals 0 days, Mr. Passwater had 100 followers. Since they gave us the growth rate in weeks, I'm going to begin by writing the model in weeks, and then I will convert it over to days. So I'm going to say f at w for weeks. The initial number of followers is 100 at t equals 0 days, t equals 0 weeks. Either way, it's 100. Now, for the growth factor, I'm thinking 100% plus 31.4%. You don't have to show this, but this is equal to 131.4%. Converting this to a decimal, I'm moving this decimal 2 places to the left. So I get 1.314 for the growth factor. And this is to the power w. Actually, instead of introducing the variable w, let's just write the word weeks right here temporarily. What's the relationship between weeks and days? The number of weeks is the number of days divided by 7. We are using the variable t to represent the number of days. So the number of weeks equals t over 7. Let's put the expression t over 7 in for the number of weeks. So here's your expression for f of t. Part B. The most popular account on TikTok has 156 million followers. According to the model found in Part A, how many days will it take for Mr. Passwater to have 156 million followers on TikTok? Include units in your answer. We are looking for where f of t is equal to 156 million. Be careful not to just put 156 right here. This 100 is just 100 followers, not 100 million. So we need to stay consistent and not just write 156 if we really mean 156 million. Anyway, so that means we are looking to the solution to this equation. We can do it in 2 ways. We can use the solver on the calculator, or we can graph and find the intersection point. I'm going to graph first. I'm missing a 0. To solve by graphing, enter the left side of the equation as y1 and the right side as y2. It should look like this. We are going to have to adjust the window. So look at this 156 million. Y max needs to be bigger than that. So I think I'll let Y max be 200 million. Hit the window button and make that adjustment. I don't know how many days it will take, so I don't know how big X max needs to be. I'm going to try 50 and see what happens. Hit graph. Wow. That was nowhere close. I'm bumping X max up to 500. Let's take a look. Alright, there we go. The solution will be this intersection point. So let's hit second trace, option 5 for intersect, move the pointer close to the point of intersection, and hit enter 3 times. Enter, enter, enter. Kabam! It will take Mr. Passwater 365.544 days to reach 156 million followers. That's about a year. We can also use the numeric solver to find the solution. So hit the math button and scroll up because numeric solver is the last option. Hit enter. Type the left side of the equation in as equation 1 and put the right hand side of the equation in as equation 2. Once you have it all typed in, it should look like this. Just hit enter. Kabam! 365.544, the same answer we got by graphing. By the way, you may wonder why I keep showing you the graphing method and the solver method when the solver seems so easy. The reason is because when you get to calculus, there are many equations that we have to solve that cannot be solved in the solver. They're just too complex and it crashes the calculator. So I want to make sure you do know how to solve equations by graphing as well, just in case you ever run into a situation where the problem solver fails. It might even happen in this course. Number 6. The number of bacteria found in a petri dish can be modeled by the function b of t equals k times e to the t power, where k is a constant and t is measured in hours. At time t equals 2.5, there were 5,100 bacteria in the petri dish. According to this model, what is the number of bacteria in the petri dish after 90 minutes? Be so careful right now. We are being asked about 90 minutes, but t is measured in hours, so we have to do some conversion. Specifically, 90 minutes equals 1.5 hours. That's 90 divided by 60. This is the value we will use. At time t equals 2.5, there were 5,100 bacteria. That means b at 2.5 equals 5,100. Using the given model, we have k times e to the 2.5 power equals 5,100. Dividing both sides by e to the 2.5 power gives k equals 5,100 over e to the 2.5. Substituting this expression back in for k, we have a complete model for b of t. To find the number of bacteria in the petri dish after 90 minutes, we need to evaluate this model at 1.5 hours. Don't forget that t is in hours. b at 1.5 equals this. All we have to do is type this into the calculator. Kabam! There are 1,876.185 bacteria in the petri dish after 90 minutes. Number 7. Mr. Passwater decides to buy a brand new 2024 Mini Cooper convertible for $39,645. The value of his car is expected to depreciate or decrease by 17% each year for the first 5 years. Let V represent the value of Mr. Passwater's Mini Cooper at time t years after purchase. Part A. Write an expression for V of t, where V of t equals a times b to the t power. The a value is the initial amount, so 39,645. The b value is the growth factor. I'm going to work that out over here. You don't have to show this, but in my mind, I think to myself 100%. And then because we are depreciating 17% each year, I need to subtract 17%. That is equal to 83%. In the formula, this goes in as a decimal. So move the invisible decimal point, which starts out here by default, 2 places to the left, and we get 0.83 for the growth factor, and then the power of t. Part B. Let V of m equals a times k to the m power be an equivalent expression for V of t, where m is the number of months after purchase. Find the value of k. V of m is an equivalent expression to V of t, so it will still equal all of this. Just realize that t was the number of years. we need to rewrite this using m for months. However, whatever expression we put here still has to give years. The number of years is equal to the number of months divided by 12. Since m represents the number of months, then the number of years will equal m over 12. Let's substitute this expression in for the number of years. This is an equivalent expression and it involves m, but we're not done because they told us to write the model in the form a times k to the m power, not a times k to the m over 12 power. I don't feel like recopying the whole problem just to make this one small change, but m over 12 is the same thing as 1 over 12 times m. So allow me to make that substitution right here. I'm writing it this way because I want to use the property that says c to the a times b power is equal to c to the a all raised to the b. We can pull the m outside the parentheses like this. In this form, we can see that the k is whatever is inside of the parentheses. We can find the value of k in the calculator. K turns out to be 0.9845. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.